Action! All right, time to start filming this here lecture part 2. Now, we're on page 352, pressure sensing devices. It's when measuring or controlling the pressure of refrigerant, air, gas, or water. And it says the terms pressure control and pressure switch are interchangeable. So you can use that back and forth, and they both mean the same thing. Pressure switch and pressure control both mean the same thing. Now it says, if you go to page 352 on the right hand side at the bottom, it says, when used as a switch, okay, so it says the pressure setting at the control, which interrupts the circuit and stops it, is called the cutout. The cutout. It interrupts the circuit and it's called the cutout. The point at which pressure setting at which the electrical circuit made known is cut in. So when it makes the circuit, the pressure control, it has a cut in. And the last thing it says, the difference between the two is the differential. All right, it's the differential. We're going to talk about this in a minute. Pressure controls can either open or close in a rise of pressure, and classifies as open on a rise in pressure or close on a rise of pressure. They can do both. Okay, so let's look at this in the book real quick. Right here. This is in your book. Okay. The first one says, it could be applied as a condenser fan cycling control. So that one will rise up on a rise in pressure. So if it's low ambient and the fan control turns the fan off, so the head pressure and the low ambient, we talked about this during condensers the week, turns the fan off. When the head pressure comes back up, this will make and allow the fan to come back on. Here, it could be applied as a switch to show a drop in pressure. This one could be applied as a low pressure cutout control. Notice it breaks on a drop. So when the pressure goes down, it cuts out. It could be applied as a high pressure cutout control. Notice this one breaks on a rise. So that one can be used to break on a rise. So these pressure controls can be used in various different ways. One way it says on 353 is the pressure switch can function as an operational device or a safety control. In fact, a pressure relief valve is a safety control, which will open if the pressure in the hot water system reaches unsafe levels. All right, now they have a little bit about water controls, so I'm gonna skip this right now until we get a couple of pages ahead. But let's talk about this real quick. In some controls, the high and low pressures are built into one housing. So you can have two pressure controls in one housing. This is called, believe it or not, a dual pressure control. All right. This is a P70LB-1. All right. If you go to a supply house and you need one, that's what you ask for. If not, they can cross it over for you. Maybe they'll have the other one. If they worth anything, they'll have something you can use. So in the HVAC field, both pressure and temperature controls increase cutout and cut-in differential adjustments. The cut-in closes the electric circuit, and the differential is the difference between the cut-in and cut-out. So I wrote that on the board. That's in your book, right there on 355 at the top. Cut-in minus cut-out is the differential, the difference between the two. Cut in minus the difference equals the cut out. So let's verify that for you a little bit, okay? Notice in picture 1444, I drew it with a little more detail right here. This is 1444, all right? Cut in, 20 PSI. That means the circuit closes and starts running. Cut out 5 psi means the circuit opens and stops running. And the 15 degrees between it is the differential. So the cut out is when it cuts out, opens and stops. You can write that in your notes. And cut in is when it closes and starts running again. Now your book also says some manufacturers refer to cutout as the low event. Cutout is the low event. Cut in is a high event. So you have a low event and a high event. It'll ask you that on the exam tomorrow too. What cut out and cut in means, and what that's how that's relating to opening and closing the circuit. And it'll also ask you about what the low and high event is. Notice we can also do this with temperature. Same thing. Cut in 20 degrees. That's the high event. Cut out is 5 degrees. That's the low event. All right? And the differential is 5 degrees. Let me see if I can move this a little closer so you can see this board better over here. All right, so you can see that what I wrote up here, this is basically everything that's in that book right there, but I broke it down and wrote high event, low event on there, closes and runs, opens and stops for you too. Temperature, pressure. So you can pause that if you need to write that down. Now, here, let's talk about this for a second. Your book goes on to say at the bottom of 355, they give you a scenario, okay? Changing the cut-in setting without changing the differential will automatically change the cutout. The range of the control is increased, so the average box temperature. So right here, we have this, okay? We have a cut-in, 20-degree high event, and a cutout, 5-degree low event. The range is 5 to 20 degrees with a 15-degree differential, okay? Now here, we changed something, didn't we? All right, what does your book say again? Changing the cut-in setting without changing the differential automatically changes the cutout. So let's add 5 degrees here. Instead of 20 degrees, we now have 25 degrees. Well, that without changing your differential, it's staying 15. That automatically changed this to 10 from 5. Because 20 from 5 is 15. So if I raise the 20 to 25 and keep it minus 15 differential, the cutout automatically rises to 10. Because 25 and the difference between 25 and 10 is 15. So all you have to do is change the cut in and you've automatically changed the cutout. The range is 10 to 25 on this one with a 15-degree differential. And that's what they're talking about on the page at the bottom of 355 right there. All right? That's what's explained on that page. The cut-in adjustment of a control is often referred to as a range adjustment because you changing the cut-in causes both the cut-in and cut-out to change. If the differential of the control is changed, the range of the control will be changed because the differential is the difference between the two settings. All right, so this is on page 356. Now, let's talk about what a pressure transducer is. Some of you who've been here a while with me already know what a transducer is. All right, you can use this and put this on something with pressure, and what's it gonna do? Look what it says, pressure transducers are devices that measure pressure and convert it into an electronic signal that is then processed by a microprocessor. So that's what a transducer does. It takes a pressure control sensing, senses the pressure and turns it into electronic signals. That's called a transducer, okay? Now, real quick, I'm gonna go ahead and erase this so we can talk about something else for a minute. Let's talk about, on the bottom of page 357, what is a high pressure control? The high pressure control says it stops the compressor if the pressure is excessive on the high side. Okay? It also says in the wiring diagram, the control appears as normally closed control that opens on a rise in pressure. Normally closed, opens on a rise. Most of these head pressure controls that are used for safety are normally closed, and they all open to protect something. If you look at 1452 right there, it says something very unusual. It says cutout is cut in minus differential. It says that right on the control. Well, you need to know what that means. The way this one works is, notice it's written with different, it can have different things written on it, like, wait. So let's say you have a 400, we're gonna go to low pressure in a minute. I want to do the high pressure first. So it may have 400, 350, 300, 250. All right, so let's say I wanted to cut out at 350. Now on this side, they have something that looks more like on a high pressure switch. It depends on the manufacturer. They'll have 40, 50, 60, 30, whatever. This is the differential. So if I wanted to cut out at 350, I'll move this arrow here on the thing with the screw at the top. They'll have a screw, and you can actually turn that, and this will move. And then I'll set my differential to 50. That means it cuts out at 350, and it'll cut back in at 50. 300. Because you're going to have to adjust it by the differential, okay? So you want it to cut out at 350, and I want it to cut in at 300. So over here is the differential. It'll say I have to do 50. That's the way it works. That's on the high ones, okay? So let's talk about now. If you have any questions, send me an email or text me now. Low pressure controls. Low pressure is commonly used in air conditioning for low charge protection. A low charge protection device. And it also says, in commercial refrigeration applications, low pressure controls are also used to cycle compressors on and off in response to evaporator pressures. Now you can use low pressure controls to actually not have a thermostat. You can take the pressure, convert it to a temperature on a PT chart, and know what pressure you want it to cut in and cut out at. And that will maintain the box temperature. That's for another chapter. Okay, right now we just want to discuss what a low pressure control is. Okay, any questions about that? They can be used to harvest ice and all these kind of things. All right. Let's see here. Oil safety pressure controls. Let's talk about them now on the next page. Oil safety pressure controls. I'm giving you the gist of everything you need to know in this chapter because we don't have a lot of time to record. That's why I'm doing this in different parts. Now, the oil safety pressure control is used to ensure the compressor has pressure, oil pressure when operating. The oil pressure. What's that, David? Capillary? What you said? Okay, good. And it also said, Hayden, what? The bathroom, look, you go this way to the left, straight left, right, right, left, right, left, right, right, and you're at the urinal. So it says, ensures compressor has oil pressure. What this does is it's ensure that you're protected from rising oil pressure prices and gasoline prices. You believe in that? Are you kidding me? Did you just fall off the turnip truck yesterday? It ensures compressor has oil pressure. That's what this is doing. So, if it's not sufficient, the control will open its contacts and turn the compressor off. The control is a pressure differential control again. Once again, it's a pressure differential control. The control, it measures the difference in pressure to determine if positive oil pressure is present. Measures for positive oil pressure. Got it? Do y'all understand what's going on right there? Now it says the compressor crankcase when the oil pumping, okay, come down some. Notice it says the difference in the suction pressure and the pump outlet pressure is called the net oil pressure. And we'll talk about that more when you get to the lab. All right? So let's say you had 70 psi G of pressure. This is at the bottom of 359, 1454 is your picture. The oil pump suction pressure is actually the suction pressure of the compressor. This means the true oil pump pressure is the oil discharge pressure minus the suction pressure. For example, if the oil discharge is 130, that means the compressor is 70 psi G suction pressure. So the net oil pressure is 60. This is a usable oil pressure and it's positive. It means the oil's moving through. Now look at picture 1455 right here at the bottom. Okay. Follow along here. You have your voltage coming in, going, and this is what's going to allow the compressor. Now look what happens here. You have a pressure switch here. Oil discharge pressure. It has a resistor that acts as a heater. This resistor right here gets hot. So when you energize these two line voltages here, this gets hot. All right? Because this has got positive oil pressure right here. Notice this is in the circuit to the resistor. It says, if the discharge pressure does not open this and stop this from heating up, it will then heat up this and the contacts will open and stop the compressor. That's what's going on in that picture right now. All right, now finally, let's talk about 361 air pressure controls. Air pressure controls. Okay, so air pressure controls. Woo, moving right along today. Air pressure controls. What is air? What is air? I can feel it. I don't see it. I can hear it, but I don't see it. What is air? Someone might tell you that it's about 20% oxygen, 78% nitrogen, and a couple percents in there are some mixed gases. The news will tell you it's 200% coronavirus. But we really don't know what's making up the air other than nitrogen, oxygen, and other gases. But that's for another day. Now, what is an air pressure control? These sensors need a large diaphragm to sense very low pressures in the system. Well, you need a large diaphragm. So what would you do if you wanted a control to work? Let's say you had a control here with some contacts in it, all right? And you wanted the air blowing like this. There's my cool dude, and he's blowing air. And you wanted to measure air movement, what would you do? What would you do? Would you put a little stick right here to measure it? Or would you put a large piece of metal like this that would blow over and open or close these contacts, depending on what you want it to do? Well, you're going to use a large diaphragm. So when the air hits it, it'll actually move. You don't want a toothpick right there, right? You want something that can actually sense the air. So in the picture, page 361 at the top, you can see that. Now this is what that does. An ice buildup on an outdoor coil of a heat pump will cause air drop. All right. When a predetermined pressure drop is detected, there's sufficient ice buildup. No defrost is needed. All right, okay, so it's telling you when you need defrost because there's less air across a heat pump coil. When electric heat is used in a remote duct, an air switch or a sail switch like 1458 is sometimes installed in the blower air passing through the duct. This control safety switch should be treated as such. It has a very light sensitive sail and will let you know if the air is on before the electric strip heaters come on because they can burn up. Air switches or sail switches are used to prove combustion air before turning on a gas valve. All right, so let's talk about a couple more switches real quick and we'll wrap this up. Switchless devices that control fluid flow. Well, we talked about a pressure relief valve. It's considered pressure sensitive. It is used to detect excessive pressure. Okay? So a pressure relief valve is used to detect excessive pressure. And it says boilers, water heaters, all these kind of things can get excessive pressure. The device can either be pressure or temperature sensitive, or just pressure sensitive. It can be usually recognized by its location on bones that's often used and placed in a high point. And you can see it, it's got a top like this. And it opens at a certain PSI. This one's set at 75. And then when it trips, it releases some stuff. Now look what it says, water or whatever you fool with. The pressure setting on a relief valve is factory set and you never fool with it. The pressure relief valve There are some things in life we don't tamper with, like Tylenol. Other ones are pressure relief valves. Leave them alone. They're factory set. You don't want to be liable for anything. You want to be able to sleep at night. A seeping, crying relief valve is bad. Change it. It shouldn't be leaking water out of it. If it is, get rid of the sucker. Water pressure regulators. We only got two things left in this chapter, so let's talk about that real quick. This pressure regulating valve for system pressure and the pressure regulating valve for head pressure control. All right? So what are we discussing here? What are we discussing here? All right? You could probably see it better if I did this right here, huh? So let's do this right here. Let's talk about a water regulating valve. You had this during condensers week, and you'll have it during when we're doing commercial too. All right. So this is a water regulating valve. Number one, water regulating valve. Water's going into the condenser. It's water cooled, not air cooled. So it needs to pick up a certain amount of heat. The pressure regulating valve for head pressure control is water cooled refrigeration systems. All right. So there's two kinds used. The other one is for system pressure and the other one is for head pressure control. First, they reduce supply water pressure to the water going to a hot water system. This type of valve has an adjustment screw on top that increases the tension on the regulating pressure. A great many boilers in home and businesses like to use 15 psi and may have a working pressure of 75, which must be reduced to the system working pressure. If the supply pressure were to be allowed into the system, the relief valve would open. Check this out. The water regulating valve controls water flow to the condenser to regulate head pressure. So if it was gonna, let me ask you this. Don't shout me now while I'm teaching good. If I wanted to control the head pressure in a condenser with water, how would I have that on the outlet or the inlet of the condenser? Notice what your book says right there on page 363, number 2. It can control water flow to the condenser. On condenser inlet. Okay, going to the condenser. That's how you're going to control it. So what happens is the valve takes a pressure reading from the high pressure side and controls the water in order to establish predetermined pressure. It's controlled by two pressures, the high side and the spring that's in it. And if we flip back a page, I told you we'd go back to this real quick. Go to page, where were we? 353. First paragraph under picture 1436. It says, a water regulating valve is commonly found on water-cooled condensers will open and close in order to maintain high pressure sides of the system. It has a spring that pushes against the high side. If the high side pressure is too low, the spring pressure pushes the valve closed and the high side pressure will increase. If the high side pressure is too high, the high side pressure pushes the valve open. More water flows through it, and it lowers the high side pressure. So that's how it works. Okay, so that's your water regulating valve. Okay, now the last thing we got right here is gas pressure regulators. What do they do? These are used in all gas systems to reduce gas transmission pressure to a usable pressure at the burner. So a gas pressure regulator regulates the amount of gas coming in, going to the gas valve inside the gas furnace. It says the pressure for natural gas is usually 5, and the burners could be manufactured to burn at 3.5 water column. Any questions about that? The last part, they just talk about a maintenance, mechanical controls, the fluids, you just have to maintain them. Any questions about any of this? All right, so that's the end of the chapter in part 2. The exam will be tomorrow morning. We'll meet in the morning. I'll text you all and we'll have a Zoom meeting and then we'll get into the exam. So I'll text you all in a few minutes your study guide. Thank you.